Okay, guys. So I've said we can collect data by counting, and we can also collect data by measurement. So by counting, basically just counting anything, the number of students, the number of packets of milks, and by measurement, measuring the, let's say, your height, weight, okay, things like that. So I've said there are two main types of data, that is continuous data and discrete data. Mpule, is there an issue? Could kindly, if you have an issue, just write it in the comment section. I'll be able to see. I can see you've raised your hand. So let me know if there's an issue in the comment section. Now we have two main types of data. We have discrete data and continuous data. Now, when data are obtained by counting and only whole numbers are there, like let's say we are counting the number of students in a class, you know, we cannot be able to get 1.2 or 1.3 students. So it's either 1, 2, 3, or 4. So such type of data, that's what we call discrete data, whole discrete data. It has to be in whole, 1, 2, 3, like you can't have point. This is what we call discrete data. Now, for continuous data, this is like data within a certain limit. Like you can have things like, let's say, height, weight, whereby you can have this as 5.4, you can have weight as 53.4, like you can be able to write it in point form. So I hope you guys get the difference between continuous data and discrete data. For discrete, you can only represent it in whole numbers, like the number of students in a class. You cannot have 1.2 or 1.3 students. Okay? Okay, guys, so those are the two main types of data that we have. Now, when we look at presentation of data, how can you present data after counting? So there are so many ways that we can present data. So we can present data using pictograms, using horizontal bar charts, using vertical bar charts. So we can present them using pictograms, horizontal bar charts, vertical bar charts, and these are not the only ways. We can present them using pie charts. We can present them using histograms. So those are just but a few ways of representing our data. So basically, pictograms basically just entails pictures, presenting them in picture form. So we can use probably symbols to present them in picture forms, a bit of drawing or something like that, yeah? So it does not matter, you're not limited, yeah? So you can just use any type of picture to represent. Now, horizontal bar charts, this is basically having your data represented equally within spaced horizontal rectangles. So let me have a drawing for that. So the first one I've said is pictograms. So we could have, let's say, so for pictogram, I could have something like this, pictogram. I could have probably just pictures representing my data. Let's say I want to represent the number of TV sets repaired in a particular shop. So let's say number of TV sets repaired in a particular shop. So these TV sets, you're looking at the number monthly. So let's look at month 1. So we have maybe January, we have February, we have March, and so on. So let's say the first month, the number is, so let me represent that as this. In February, we have this. In March, we have this. So those small rectangular diagrams that I've drawn are basically just pictures representing the TV sets that have been repaired each month. So basically that's how a pictogram looks like. Now, I hope you guys have noted that. I would like to draw a horizontal bar chart so that we see how exactly it looks like. So what of a horizontal bar chart? Now for a horizontal bar chart, it would look something like this. So let's say we are representing the number of sales against maybe sales against distance traveled in miles. So let's say we have something like this. So since it's horizontal bar charts, there are bar charts that are cutting across like this. And one thing you need to know about bar charts is that in between the bars, there is a space. So there's some space. And then I can have notes. I'm just like doing rough drawings, but this bar chart is supposed to be like of same width and same width, basically. Like this is supposed to be equal to this. So having something like this. So this basically, let's say this is SPQ. Then this represents salesmen and the distance they've traveled. So on this side, we have salesmen. And on this other side, let's say we have this as representing 0 all the way to, let's say this is 0, 100, 200, 300, okay, 400, all the way to, let's say 500. And this represents distance traveled in miles. Distance traveled in miles. So this is an example of a horizontal bar chart. So for a vertical bar chart, the same thing, just that now it's vertically drawn. Vertical bar charts, it would be something like this. So we would have this. So obviously, this is going to be like this, something like this, with the space in between the bars. So something like that is what would be our bar chart. So whatever you have on this side and this side, but basically that's how a bar chart looks like. And what of a pie chart? So a pie chart, this is a circle, guys. So excuse me, I'm not very good in drawing. So that's supposed to be a circle. And a pie chart having values. So we all know that 360 has an angle of, a circle is of 360 degrees. So having this different, each value representing a particular angle. So this is basically how a pie chart looks like. And finally, if we are to have our data being represented as an histogram, so allow me to draw it here so that you can be able to see all of them. So for the difference between the histogram and the bar graphs is that the bar chart is that the histogram have the bars together, like there's no space in between the bars. So for the histogram, we'd have our bar, let's say there, we would have our bars like that. So with you having your X axis here, having X values of whatever you're representing, and this is your Y axis, having the values of whatever you're representing on the Y side. So this is it, guys. This is it. So now, presentation. Let's look at presentation of grouped data. Presentation of grouped data. So if you're given some grouped data, or if you're given some data, let's say, and you're being told to group that data, so how exactly do you go about grouping the data? So let's say you're given some data and then you're being asked to write a frequency distribution table. You group it. So frequency distribution table. Now, guys, let me mention one thing, because I've just gone straight ahead to telling you grouped data, but I've not told you what grouped data is. As we started, I said we have two main types of data. We have continuous data and we have discrete data. This continuous or discrete data, they can either be grouped or ungrouped. Now, grouped data, this is whereby you're given probably in sections. You're being told probably from 7 to 10, we have this amount. From 10 to maybe, from 10 to let's say 13, we have this as the frequency. From 13 to this, we have this. While for ungrouped data, this is whereby you're just randomly given data. You're being told the marks of particular students in a class are 2, 3, 30, 40, 60. It has not been grouped. Like, you're not being told from this section to this section, we have this. So we have grouped and ungrouped data. Now, if you're given some ungrouped data, you can be told to draw a frequency distribution table or to group that data particularly. So most of the time, it's always up to you. If it is not specified, it is always up to you to know how exactly you can be able to group your data. Okay, so let's say this is the random data that we've been given, and I would like to have another page so that can be able to write all the values of the data. So we have 81, 83, 87, 74, 76, 89, 82, 84, 86, 76, 77, 71, 86, 85, 80, 82, 83, 79, 82, 81, 76. Okay, let me stop there. And then you're being told the data given below refers to the gain of each of a batch of, let's say, 40 transistors, expressed correct to the nearest whole number. So the question is, form a frequency distribution for this data. We want to form a frequency distribution table. Frequency distribution table or frequency table. Frequency distribution table. So forming a frequency distribution table having 7 classes, and it has been said having 7 classes. Having 7 classes. So how do we go about that, guys? So if we want to form a frequency distribution table, and let me have here also 70, 90, and 86 again. So having 7 classes, if we want to form a frequency distribution table having 7 classes, we have to check what's our highest and what's our lowest, so that we can be able to know each class has a range of how many, so that we are able to know how many classes we are going to have. Now, looking at this data here, what's the lowest? As we can see, 70 is the lowest. Okay, so we have 70, and what's the highest? The highest is 90, right? The highest is 90, as we can see here. So what do we have? Now, if 70 is the lowest and 90 is the highest, so this is what we are going to do. The range of the data is what we are going to look for. And how do we get the range? We get the range by obtaining the value of the smallest member from the largest member. So we are going to get the range by obtaining the difference, that is 90 minus 70. Yeah, I hope this is the lowest and this is the highest. So 90 minus 70, what does that give, guys? That gives 20, yeah? But how many classes have we been told to have? We've been told to have 7 classes. So 20 divided by 7, that will approximately give, so that's approximate to about 3, yeah? Yeah, that is approximately 3, because if it was 21 here, then we'd have gotten 3. So it will be 2 points something, which approximates to 3. It's approximately 3. So if this is approximately 3, then it means the range that we will have in between the classes will be 3. So let's say if I take 70, I will take 70, 71, and 72. So it will be from 70 to 72. Then if I take 73, 73, 74, 75, so I will move all the way to 75, then 76, 76, 77, 78, and so on. So from 79, we go all the way to 89. Sorry, 79, we go all the way to 81. Then from 82, we go all the way to 84. Then 85, we go all the way to 87. Then 88, we go all the way to 90. Now, a frequency distribution table basically entails us having our data here. So this is like our data, whatever it represents, if it's the marks of students or, yeah, and then frequency. So how many times does it appear here? That's basically the frequency. So numbers that are between 70 and 72, like in this range, we are going to look for numbers which are 70, 71, and 72. And how many are they? So let's see, 70, 71, and 72. So this is 1. And then 70, 71, and 72, that's 2. We only have 2 there. Okay, numbers 73 all the way to 75. So let's see, 73 to 75. So we have this 1, 73 to 75. So that is 1. Is there any other? That's it. It's just 1. 76 to 78. So 76 to 78, we have this 1, 2, 3, 4. So we have 4. 79 to 81, 79 to 81. So we have 81 over here. This is 1. 1, 2, because this is 80, so 2, 3, 4, so that's it. These are 4 values. Then 82 to 84, so 82 to 84, we have this 83 is there, 1, 2, 3, 4, 5, 6, and that's it. So those are 6 values. 85 to 87, so 85 to 87. So 85, let's see. This is 86, it's in between. So this is 1, 2, 3, 3, and then we have this 4. I hope we've counted all of them. So that is 4. Okay, 88 to 90. So 88 to 90. So let's see, 88 to 90. So we have this in between, 1, 2. So those are 2 values. So basically, guys, this is a frequency distribution table. That's how you group your data. When you're given this set of ungrouped data, this is a set of ungrouped data. This right here, was our set of ungrouped data. So you can group it by drawing it into a frequency distribution table. So representing where if you want to get the range, like we've been told to have 7 classes, you get the range that is the highest minus the lowest, and then you divide by the number of classes that you're supposed to have so that you know the particular range. So this is called a frequency distribution table. This is called a frequency distribution table. Okay, guys, so I hope that is clear.